All right, let's go ahead and get started. My name's Tovio Roberts, and I'm here with Clark Walker. We're your instructors. I'm mostly going to be focusing on kind of the integrated Python and stats, a lot more in the stats domain, and Clark is going to be focusing a lot more in Python. You'll see that the first couple weeks, Clark will be teaching a lot more. In the last couple weeks, I'll be teaching a lot more. And we're generally going to be covering somewhat different topics. You'll notice that as we go. Let me tell you a bit about myself. My background is in language studies and machine learning. So that's my academic background, a lot of focus in natural language processing. Professionally, I've done a lot more in computer vision and some research in computer vision as well. I'm also a musician and a painter. And I got into software development initially a long time ago, actually, and transitioned into data science. And I was a software developer for years and years while touring with circuses, mostly performance troops in Europe and Eastern Europe. Let's see, anything else? And Clark, do you want to give a quick introduction of yourself really quick?
Sure. I'm Clark Walker. I'm going to be like Tovio said, I'll be focusing mostly on Python with you all. My academic background is actually centered around being an alum of Galvanize. I graduated the web development immersive, which was sort of the predecessor to the software engineering immersive. It was a 6-month full-time immersive program that would really take you from sort of zero all the way to being a full stack developer. And for me, that was sort of a means to an end of breaking into the industry. And from there, I know Tovio from outside of Galvanize, and Tovio helped me get a job here, and I broke into data science that way. So that was sort of how I got my foothold in the industry and kind of went out and branched out from there. One of my goals from going to the SEI was to get to the point where I could learn languages sort of easily and kind of learn different languages. So I've worked in a number of different languages, just doing personal projects and kind of toying around in languages like Rust and JavaScript. And I did a little bit of Elm and Haskell, which is kind of an obscure one. I've also played around with C and C++, and I really enjoy kind of low-level programming and that kind of thinking. So although it's much less a specialty of mine than Python. I'm also a musician. I play a number of instruments and actually play with Tovio occasionally. I don't know. That's me in a nutshell.
Awesome. Thanks, Clark. So the first, 2/3 of today is going to be focused around kind of explaining what this course is going to be about, the resources that are available to you, and how we and our team is how we're here to facilitate your path into the data science space in general, right? One of our primary goals is for you to pass the technical interview. The next goal from there is for you to be prepared for day one of the actual DSI, depending on where you're going to start that, when you're going to start that. And so with that, I'm actually going to share my screen. And as we go, I'm going to show you various resources, the materials that we have on hand, and explain some things. And I'll just do this topic by topic. I'll try not to take too long in this, but we'll probably take a break right at the point where I finish up. And then we'll take a 5-minute to 7-minute break. And then I'm going to hand off to Clark. Clark's going to do some very intro stuff in Python for everybody. So let's start off with just a brief overview of the course. It's a 5-week course. And as you can see, we scheduled this Monday through Thursday, 6 p.m. to 8 p.m. Pacific time, which translates to 7 to 9 Mountain Time, 8 to 10 Central Time, and 9 to 11 Eastern Time. Our instructional team, and this is actually our entire prep team. It's me, Lance Bardo, Remy Arata, Devin Dijon, Clark Walker, and David Coleman. Our team admin, not necessarily a technical admin. We're all, the rest of the team is actually much more technical in terms of the data science space and Python and stats, probability, all the machine learning related things. But our admin is David Coleman, and he's the person you would contact just in regards to administrative things. Like if you want to defer to the next course, you can either contact him or contact me. If you want to, let's say, you're seeking a refund for the course, you would talk with David Coleman. But the rest of us, we're all here as mentors and as instructors. So this is on, well, I'll show you where this is in just a moment. So we have a GitHub repository dedicated to this course, and that's kind of a static place, one-stop place for pretty much all the information you're going to need. So let me show you that. Really quick, our schedule's there, source of truth, right? There are going to be links to all of our class recordings. I'm recording right now, just so you know, I'm recording. So please refrain from coming off mute or anything like that. I'll generally have headphones in, so even if you do come off mute, it won't get caught in the recording necessarily. But if you do come off mute before we stop recording, I have to go in and clip that out manually, and then recode the video, and it ends up being a little bit of work, a little bit more work than just taking the recording and putting it online. So just so you know, that's what's happening on our end. Yeah, and also GitHub. GitHub is a place where you're going to spend a lot of time in your future. Sometime in the immediate future, but a lot more time. Once you are in the DSI, even a little prior to the DSI. Once you're in the DSI, and definitely post DSI. GitHub accounts tend to act as your technical portfolio. That along with maybe a website, but people get hired off of the virtue of their GitHub accounts, and in a lot of cases, just so you know. So this is GitHub. See this little cat octopus thing silhouette up here. That's how you know it's GitHub. And this is our repository. This is going to have all of our slides. As you can see, it's going to have all of our code, all of our source code, which is going to be in two directories, Python and stats. Everything I do will go in the stats directory. Everything Clark does will go in the Python directory. And then we have our schedule here just in the landing page of the repo. And if I say repo, I mean repository. It's just what everybody says, a GitHub repo. This is a GitHub repo. So I'll link you all to that right now. And up at the top here, we've got important links like the Zoom link. We don't put the password for the Zoom session here, but if you go to the initialize section in the Learn Materials, the password's there. Obviously, if you're in here, then you probably put in the password at some point. We have a YouTube channel, and recordings are going to go up there in a special playlist, which is linked here from the front page, from the top of this README document that we're looking at. I also have a lot of resource links here. One of the things you'll want to do early on is add this Chrome extension if you're using Chrome that will allow the rendering of mathematical formulas. And I will drop this in the Slack right now in case you want to do that. This will just allow you to see math formulas that are rendered to be rendered properly in GitHub. Since we use LaTeX, which is a kind of a mathematical markup language, and it doesn't always render in GitHub unless you look at it a certain way. this is just an extension so that all of those will render. MathJax is the version of LaTeX we use, right? There's some information about how to use MathJax, but we don't need to worry about that now. We'll get to that quite a bit later, actually in our last week of this course. And, there's just supplemental materials here, whether it's in terms of statistics, just general math, visualizing plotted functions and things like that. And then we have a link to one of Galvanize's podcasts called the Tech Pivot for Spotify and on Apple Podcasts. And then this is a really fun site to look at if you get a chance, Visual Go. So the general format day by day is we will link to the slide decks that we're using in the course schedule. So notice Welcome to Premium Prep and Introduction to Python. I also put these topics in our post for the class. In general, I'll post for the class about half an hour to an hour before the class starts. Either I will or Clark will, depending on who's teaching. Today, obviously, we posted a few minutes before class. That's me. I was rushing around trying to get some stuff taken care of. And I posted just before class. In general, I'll post half an hour to 45 minutes before. So we've got 2 topics we're covering, Welcome to Premium Prep and Introduction to Python. That probably looks more like mostly this one topic of Welcome to Premium Prep. These are also slide decks, and I can open this up over here, and the whole slide deck is rendered as such. And notice this is the same thing as what I'm presenting from here, which is a text editor called VS Code, which is the primary text editor that we do use in the DSI. So I'll end up presenting probably from here if I'm showing slides. And in more cases than not, I'm actually going to use a drawing tablet and a code and a text editor for most things. And I won't necessarily show slides. I might show some screen captures. So that's a lot of our documentation, right? That's all on GitHub. Let's talk about just some very basics of lecture etiquette. So we prefer that you have your camera on. That is really preferred. And the reason we ask that, we ask that you consider doing that. We don't require it, obviously, but we ask that you consider doing that because people tend to be more engaged when their cameras are on. I don't know, some social construct of this remote world that we're living in right now. That tends to be the case, and we definitely have seen that. Please set yourself to mute by default. We can mute you as the administrators of the course. We can mute you, but I actually have to stop screen sharing in order to mute anybody. So there might be times where I'll hear a little bit of chirping or something, and I'm like, oh, somebody's mic is probably on. I'll just say something. I'll say, hey, I think someone's mic is on. Could everyone check and just check really quick, turn your mic off, just to make sure. Please be appropriately dressed. I'm saying this from experience. There have been a couple moments where somebody doesn't have a shirt on or something, and that it's not. No judgment, but also not the space for it, right? So, yeah, that's. I think maybe that should be obvious, but it's not apparently. Also, please limit your questions to the lecture thread. So, if you notice in this, we have this thread going under the class posting for today, where I say, "Hi all, class will be starting at the top of the hour," etc. And there are 24 replies so far. Everything that we reply is going to go in there for this class. That just makes it a really easy point of reference, right? So for one class, everything will live underneath those replies. So try to do that. If you post outside of that today, I'll probably just like screen capture it and throw it into the replies just as a reminder. But yeah, it just keeps everything a little bit cleaner. It doesn't mean you always have to post in replies, but Slack does tend to get really messy very quickly if you don't respond to replies. So yeah, and ask questions in there. And there might be time, well, there's almost always time at the end of class where I say, okay, I'm going to stop recording now, and feel free to ask questions. Feel free to come off mute at those times, right? And those don't go into the recording, but but we try to answer those, in time allotted at the end of class. So a little bit more about those lecture recordings. We host those on our YouTube channel. Like I said, I'm going to open up our channel right here. I definitely recommend that everybody follow this channel, subscribe to this channel, and I'll drop the link in the Slack here as well. I think I'm seeing this from an administrator point of view, but if you go to the channel, we have a lot of stuff here, okay? We have all the videos that are embedded in the Learn materials. For one thing, they're all here. We also have, all the recordings, right? We've got, for example, here's a playlist that's currently empty, but after tonight, it won't be empty. The class from tonight will be put up here in this DSI Premium Prep Recordings 2021 April cohort. And we've got a bunch of other little things in here as well. So let me just scan through this. Oh, actually, let's not scan like that. Oh, I accidentally started that playing. Let me jump back over to this list of playlists. We have some miscellaneous videos, just, some fun things. There's also a series in here that I add to now and then called Latent Topics in Data Science. A lot of this is coding some more complex things from scratch, right? So, coding SIR model in Python or Dijkstra's algorithm, or some introduction to image processing like convolution and image filters. This is a little more advanced. It's helpful to have some basis in Python before you get to this, but it's all here. So this is a playlist to come back to. And there's one here, making a simple paint app using Kivy and Python. This is super easy, it's 35 minutes. Even if you're a beginner, I think you could probably put this one together. So yeah, there's a lot here, and we host our recordings up there. In general, like I said, we won't say your names in class, and we do have to, we feel compelled to clip out your voices if you do speak. So please don't come off mute unless we say it's cool to do that. All right, so goals. Our goal here is to get as many of you as, all of you who want to get into the DSI, who want to get into the data science space. We want to help all of you get there, right? That's our goal. At the end of the day, that's really what we're looking to do. We recognize there is a diversity of backgrounds. Some people have never coded before. Some people have very little to no, rigorous quantitative background. We recognize that. Our materials are geared toward supporting everybody, and our model for instruction in general is also geared toward that. We have a lot of things built into the way that we do this that are meant to help everybody at the level that they need to be helped, right? And a lot of this also is self-direction. We can help you with goal setting early on. That's something we very much enjoy doing. Like, here's where, figuring out where you're at, figuring out what you need to do to get to where you want to be. This is all part of what we're doing. We do ask that, all of you should be registered. I know there might be some access issues, but all of you should be registered for a specific Learn cohort. And I can pull that up. I'll pull that up over here really quick. It's it's this Premium Prep April 12th to May 15th. All of you, or most of you, are probably also registered for the Basic Prep. What we ask is that you do work in this April 12th to May 15th cohort specifically, because we want to keep an eye on your progress. And if you do work in the Basic Prep, it's not that we can't keep an eye on your progress, but we don't keep an eye on your progress in relation to this course, if that makes sense. So we prefer that you work in this cohort on Learn. And anybody who's having issues accessing this cohort, I'm going to, I'll try to help you resolve that maybe at the end of class. And if we can't figure it out then, I'll get with the Learn team tomorrow and work with them to figure that out. By the way, this is our learning platform called Learn, right? A little bit confusing sometimes because I might say blah, 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 learn, and it might sound like I'm using that semantically, not in reference to this platform, but you know, this platform is called Learn. All of our learning materials are on Learn. All right. Some of you have, or many of you actually, have been in this class before, and that's great. Welcome back. You are likely a more advanced student than people just coming in, and there might be people coming in who are more advanced. And what I have to say in regards to everyone kind of in that camp is that you know, we're available to give you more materials to advance you further. And if you are closer to being ready for the technical interview, we're going to encourage you to take the technical interview as soon as possible. And then we'll actually give you more formally a set of materials to work on in preparation for day one of the DSI. So, you know, in the first couple of weeks of this, especially, we're going to be looking at some fairly elementary topics in the realm that we're exploring. We're building foundations, right? If you're a more advanced student than that, I personally don't want you to feel frustrated or bored with it, right? So you can definitely reach out to me. You can reach out to Clark, and we can give you kind of modified assignments like, hey, you know, go try to figure this out, or work through these materials. Or we'll give you some kind of strategy or some reading materials, depending on where your interests lie. Expectations.
Real quick, can I jump in?
Oh yeah, go ahead. Go ahead.
Someone on that note. Sort of the flip side of what Tovio was just talking about. If you're a more advanced student, we're available for that. For the beginner folks, part of our model is that we offer like one-on-one support. I mean, this applies to everybody, no matter if you're a beginner, intermediate, or more advanced student. So like, I know this is covered in other places, but I do just want to reemphasize this, that we are available for one-on-ones. And the pacing of this class, we have a lot of material to get through in a fairly short amount of time. And the way that we can help support you if it feels like it's going very fast is offering one-on-one support. We have other ways of supporting outside of class, mentor meetings. We have, I lead a study hall 3 times a week, Monday, Tuesday, and Friday, and that's a venue for you all to come and ask questions. I'll probably remind you all of that a few more times as well. We have a study hall channel, and I'll post the link, and I live stream it. You can ask questions in Slack. Also, oh shoot, I had one more thing. One-on-one meetings, study hall, and oh, I'm sorry, slipped my mind. Yeah, that's we're here to support you as best we can. Oh, I remembered. We allow people to reattend premium prep if you need to or want to. You pay the one time, and then you don't have to pay if you want to take it again. You don't have to pay again. So you can you stay on as long as you need to, and when you get into the DSI, you get the cost of admission into this refunded, which I'm sure you all know. But okay, just wanted to mention that.
Cool, thanks, Clark. Yeah, I definitely don't want to make it sound like we're only supporting advanced students. Our goal is to support everybody who wants to get there and who is, you know, definitely we want you to make progress, and we want to be able to see that. And in that vein, in terms of expectations we have, you should work toward completion of challenges on Learn. And let me just show you a quick example of one of those. So let's go into Python basics, for example. And in Python basics, we've got this overview, and then I'm going to just click on common data types. And we've got this lesson on common data types, blah, blah, blah. This is something you're going to learn very soon. And here's a challenge, right? Common data types challenge. What will the following code output? The type of -7. Well, maybe that's a float. Maybe it's an int. And it turns out that it is an int, and I got that correct. What we see is a high correlation of people passing the technical interview with completion of challenges on Learn. So that's not to say that this is the end all be all, but it does help you to practice. And so we definitely encourage you to complete these challenges. We want you to attend lecture. We don't keep attendance. We do look at it later for our own internal statistics, but we encourage you to attend lecture. And if you can't attend lecture, to watch the recordings. It's understandable. A number of people are on the East Coast. That's one of the reasons we provide the recordings. Another reason is that we're not trying to, put up any sort of wall to entry. So, this course is really about giving a structured learning space and, direct interaction with instructors. But we make these lectures available online as well so that, if somebody wants to study this stuff asynchronously, they can go through those lectures and they can access the GitHub repo and all that stuff. We're not really trying to gate anything here. If we have kind of a homework that exists outside of Learn, there are only a couple things like this, just some optional homeworks. We ask that you try to complete those things. Sometimes those will be more challenging, but there's only a couple of them, and we'll point them out when they occur. And really, one of the most important expectations here is that you ask questions. If you're stuck on something, and this is going to be true, like basically for the entirety of your technical career, if you're stuck on something, you need to learn how to ask questions in regards to it, whether that looks like Googling, whether it looks like, for this time, asking in Slack, right? Ask in the Slack channel. And, if you have a question on a specific item, right, in Learn, let's say, you would say, I'll just put an example here. It would be something like, I'm having trouble understanding why, -7 is an integer and not a float in challenge 1 at, and, you would put this in the actual channel, though, not necessarily in a thread. And then people can respond in a thread on your post, right? And they can help you forward. I'm going to talk a little bit more about that. Well, I'll talk about it now. When people ask questions in Slack, don't give them the answers. Try to lead them forward through hints and questions, right? Using kind of a Socratic method approach. So I wouldn't say, in answer to this -7 integer question, I wouldn't say, well, positive and negative whole numbers are integers. I wouldn't necessarily say that. I wouldn't say, well, number 2 is the answer, right? I wouldn't say something like that. I would say, well, what makes 7 different from -7? And I would ask, well, describe to me what a float is. How would you define a float? And sort of reason with the person in that way. What we see is a lot of peer-to-peer help in Slack, and we highly encourage that. We definitely encourage you to help everybody else. Data science is a collaborative space. Software technology in general is a collaborative space. It's when it's a competitive space, it can be pretty unpleasant, and we're definitely not encouraging competition in the space. We're encouraging you to challenge yourself and help everybody else, and we're all trying to get there, if that makes sense. Also, you can't expect to just attend lecture and have that work in terms of learning everything. The analogy I make here is, let's say you want to paint landscapes. You can't just watch Bob Ross for hours and hours on end and expect to become a good painter. You have to paint, right? And coding is very much like that. Coding is a creative enterprise. It's creative and technical. It's kind of a unique thing in the human experience. And you need to practice a lot. There are a lot of avenues for practice, and we'll talk about some of those in a bit. I already talked a little bit about the materials, but let's look at the sections in Learn. So we've got this initialize and onboarding section, which just has the basics of this specific cohort. We have this welcome to data science prep section, and this just has some basics, right? About prep in general, and some guidelines for using Slack, some guidelines. Here's a video on how to share code in Slack, things like that. Schedule for study hall, and mentoring, which we alluded to, and I'm going to talk a little bit more about in a couple minutes. So we've got intro to Python, we've got intermediate Python, and we've got intro to statistics, and then preparing for the technical interview. So if you think about this, anything below preparing for the technical interview is not necessary for the technical interview, okay? In fact, you don't need to complete even all of these materials in order to be ready for the technical interview. Not necessarily. Some people are going to be able to go through a lot of these and pick and choose what they study and what they complete, and then and be ready for the technical interview. Some people have backgrounds that will help them with that. But everything up until this, up into and including this preparing for the technical interview section right here, is relevant to the technical interview, okay? Everything after that is sort of, things that you'll want to complete prior to the DSI, like setting up your development environment. This is pretty important. There are questions around this that are going to come up a lot, and we're going to address a lot, like, why don't you support Windows machines in the DSI? And how, I'm having trouble with my Anaconda install and things like that. It's definitely okay to talk about those things in the course and to ask us questions in regards to those things, but those things are not necessary for the technical interview. We also have some extra practice problems here. These, I'll probably move these up here somewhere, but this is just to get more practice. Obviously, that's what that's for. There are two more sections. Only one of them is showing here right now. I need to add in the other section, but I can show you what those are, actually, if I look at the basic prep. So at the bottom of basic prep, we've got further studies. It says very clearly, not required for the TI. TI is just technical interview. Further studies is parallel materials to what we call pre-course. Pre-course is a set of things that you have to finish before day one of the DSI. So you start working on those after you pass the technical interview, and you have to complete them before the DSI starts. We also have an advanced materials section. Really, it's just advanced Python at this point. We're going to expand on that, but advanced Python is, you don't need to write Python in the way that, in these advanced ways, but if you feel particularly solid in Python, I definitely encourage you to go and look at this advanced Python section. And I'll update our cohort to reflect what's in that basic prep, what I just showed. So we talked about those materials. We have a bugs channel, and I think everybody is in the bugs channel. I assume everyone's in there. It's just called bugs. If you come across a copy error, grammar issue, spelling, or something like that, and it irks you particularly, or if there's a challenge that you feel like there's something actually wrong with it, or a mathematical formula that you're like, this is wrong in some way, we do our best to copy edit everything, but things fall through the cracks. If you've ever maintained a massive body of changing materials, things fall through the cracks, and we rely on people to point those out for us. So if you see something, definitely point it out to us, and we'll fix it pretty much immediately. I already talked about the lecture format a little bit, right? 2 hours Monday through Thursday, 2 hours on Saturday as well. Although the class start time on Saturday is 11 a.m. Pacific, and it's not an evening class. It's that early after, or late morning or early afternoon class, depending on what time zone you're in. In general, the way that we teach class, and this varies depending on the lecture, we'll cover a topic for anywhere from 5 to 15 minutes. We'll have a challenge, like a breakout, where we say, okay, you're going to go code this thing. Here's the challenge, go code it. And you're going to put your code, your solution, whether it's code or a response of some kind. It might be like a short answer response or a number. You're going to put that in the thread for our class. So we do that, rinse and repeat. There are, I'll tend to have a few, well, actually, I think Clark has a couple as well, more concept heavy lectures, right? Like, error handling would likely be a more concept heavy lecture. When I get into discrete distributions, it tends to be more concept heavy. There's less breakouts, but as I'm coding, and I will be synchronizing my code with GitHub, right? And I'll also be posting my code into our Slack thread, all right? So the idea there is that you won't fall behind. If I code something, I want it to be available to you so that you can use it as we go through the materials. It's going to be very helpful. Like if I code a median function, let's say we have a median function challenge, a few people will successfully code a median function within that time. I'll show how to code it, but then I'll copy and I'll paste that in so that if we have a challenge that asks you, compare the median and the mean of these two sets of data, then you can do that. You'll have the function to do that. You'll at least be able to use it, even if you're not ready to code it at that point. Clark mentioned study halls. Those are currently Monday, Wednesday, Friday, from 3 to 5 p.m. Pacific time. And those really vary depending on the students who are watching, right? So students ask questions, Clark interacts with those questions, codes things out, live codes things out, explores concepts. If there aren't questions coming through, there will be more focus, say, on a specific topic in Python or something particularly interesting to Clark that he wants to talk about. So we do announce when those go live. There's a channel specifically for that called Study Hall. And so you'll be able to see the link to our YouTube stream in that channel. So a big part of what we do, what our team does, is we mentor. And mentoring is going to be a little tight for the next couple of weeks because we're leading up to a DSI start date. So our bandwidth gets constricted a little bit. But in general, leading up, in general, the first couple months after the DSI starts, we are very available. And what we do is we meet up with students one-on-one, anywhere from a 15-minute to, say, an hour session, depending on the topic and depending on our time availability. And we will either work through things with you, or we'll kind of get a sense of where you're at and give you some strategies, right? That can look a couple different ways. If you're really stuck on something, like if you're really stuck on one of the classics is print versus return. Tons of people get stuck on this. The difficulty of differentiating a print from a return. It makes a lot of sense for you to meet up with one of us, and we'll walk you through what that difference is. And in general, when that happens, people will come away and that's really fixed in your head. This is the difference between print and return. So we're available for that. We can't always be available, just fair warning. We have a lot of students, but we do our best to meet with everybody who is looking for mentoring. And, we might trim that at once a week or twice a week, depending on the student. We always want to see you advance. We always want to see you getting better and practicing on your own as well. So you can reach out to any of us. In general, I imagine you'll reach out to me or you'll reach out to Clark for mentoring. You'll also occasionally receive an email saying, probably from Lance or from Remy, asking, hey, do you want mentoring? I noticed you're this far in our materials. Are you stuck on anything? Or I noticed that you stopped working on the materials for a few days. Do you want to meet up and go through something? So that's a big part of our model. short story were available for mentoring. You can also, if you're registered for this course, you can also defer to the next course indefinitely. And somewhere in the last week, couple weeks, people usually have a sense of, oh, you know, some people will have a sense of, oh, I really should take this again. In most cases, you'll just message me really quick and say, hey, can you add me to the next cohort? And I'll do that. You know, we also have a form that someone might share with you. Either way, you know, anybody who wants to take the course again can definitely do that. And you can do that as many times as you want. We don't put any limitation on that. And the idea being that everyone takes a different amount of time to get to where you want to be, you know, and there's nothing wrong with that. Actually, that's a really powerful sentiment, because some of the most amazing developers I know who went through the DSI, they studied for like a year, right? They prepared for a year to go into the DSI. And, you know, starting from no technical background whatsoever, came out of it very, very strong. And other people I know have, you know, they looked at the DSI, they found out about it a few weeks before the start date, studied Python for the first time for like a week. And this is a little bit of an outlier person, but I've seen it more than once. Learned Python really well, and then took the technical interview, slayed it, and then did great in the DSI. And that person exists as well. That person is no more valid than the person who takes 1 year. And I want to be very clear about that. You know, if you're a better coder, that's awesome. If you're, you know, better at math, stats, prop stats, awesome. But the idea that we have here is that we can ramp anybody into having this skill set. So I want to be clear about that, and that you can defer as many times as you want in this course. We'll continue to support you. Supplemental materials. If you take the technical interview, in almost every case, I'm going to recommend that you read this one book that I think is really good for everybody who's going into the DSI. I'll mention it later, but I can give you a lot of other materials to study if it's in the realm, especially if it's in the realm of natural language processing or image processing. Those are where my primary skill sets are. I've got a lot of materials that I have firsthand, you know, experience with either academically or professionally. And I definitely recommend, if you have a specific interest set, learning those things sooner than later, right? If you want to get into convolutional neural nets, learn some image processing, learn what convolutions are, right? Learn some basic properties of images. That's going to help you a lot. Now, if you feel very, very far ahead, whether or not you've taken the technical interview yet, and you want some supplemental things, reach out to me. I can help you with that. Reach out to Clark. He can help you with that. We definitely have suggestions, and we'll pick your brain about what you're interested in and give you some, you know, whatever's relevant, we'll share with you. The other thing, and I really strongly advise you to take this advice. There's a site called Code Wars, and this is what it looks like. This is a little bit small. Code Wars has a ton of challenges in it. Code Wars is not the only site for this. There's you know, HackerRank, there's Leet Code. There's one other one I can't remember, but I like Code Wars a lot personally. If you want to practice Python outside of our materials, definitely sign up for one of these sites. You are going to, this is a place to do repetitions. And, you know, coding is a creative exercise, but it also takes repetition. It takes repetition. So, you know, that can look a lot of different ways. You can go back through the learn materials and do problems again. That's fine. If you want new problems, new challenges that you haven't seen before, I highly, highly suggest Code Wars. And, you know, if you're a beginner, you're going to do difficulty level 8 problems. It's switched, right? The level 8 problems are the easiest. And, you know, like here's a function that you would write to make something uppercase, to make a string, you know, make a word or a sentence all uppercase. And so you would write this function. and it gives you points when you do it. And you know, that's really the whole story with Code Wars. It's a place to do repetitions, and it gives you points. So it's a little bit gamified in that way. All right, so Clark, could you paste in a link for Code Wars really quick? Just so,
sure. Yeah,
people have it there.
I'll post that in.
Awesome, thanks. So the place you would apply for the DSI is listed in this slide. If you apply for the DSI, you gain access to an enrollment advisor. So there are questions that I'm not good at answering. Clark's not good at answering. No one on our team, honestly, is great at answering the administrative questions around the DSI. We are very focused in the educational materials. We do a lot of teaching. We, a lot of writing of curriculum. We're not as familiar with the administrative process. So if you have administrative questions, you can gain access to an enrollment advisor after you apply for the DSI. And I'll drop this link into the Slack. Okay. So I know we're kind of like flying through these things. It's always that kind of, the kind of orientation days are a little bit sleepy, and I don't want to put anyone too much to sleep. So we have this technical interview. The technical interview, the TI, it's about 45 minutes long. It's, we test you on your ability to express statistical concepts using Python. It's very heavy on lists and dictionaries. That's pretty important. It might have some randomness, some random analysis of random processes thrown in there. I spend kind of a lot of time working on problems in this course that look like things that are in the technical interview, okay? Especially when we get to discrete distributions. There's something I call a general analytic approach, and our technical interview sort of uses this analytic approach. So I'll look at it from a high level view, and then we'll look at a bunch of example problems when we get there. This link in this slide is probably broken, but let me just show you the section in Learn, preparing for the TI right here. There is a playlist that has about 10 videos in it. And those videos are very, very indicative of the kinds of things that are on the technical interview. So the playlist is embedded in this technical interview expectations lesson in the preparing for the TI section on Learn. So there's also this Python built-ins to know, which looks broken a little bit at the moment. There was recently an update on Learn, just fair warning. There was recently an update to the actual platform that broke some of our code cells and things like that. So if you see something like this, don't worry, we're in the process of fixing all of that. So, this is the kind of thing I'm gonna make a note to myself to get back to, but yeah, this is has a list of all the functions that we would expect you to be familiar with, okay? It looks like a lot. Turns out that a lot of these are fairly easy to acquire. We're gonna cover most of them in this class. Yeah. Oh, sorry, one last thing about the technical interview. So there's a coding challenge that you'll have to complete in order to schedule your technical interview. We can't help you with the coding challenge, at least not directly. We can't say, we can't help you forward with it. What we can do is clarify the problem. So to reach the coding challenge, or you can access the coding challenge after you apply to the DSI. It's in a dashboard right there. So you would complete the coding challenge, and then that will open up a scheduling agent to book your interview, okay? In general, the interview cutoff is 3 weeks before the DSI start date. For people in premium prep, that extends to 2 weeks. We just give you an extra week, especially depending on the end date of premium prep. And at times you'll have to schedule it. If you are going to do a late interview, you would have to schedule with us directly, but and not through that portal. Okay, so kind of back to a high level view. I said this before, we're not gatekeepers. We're really not trying to gatekeep. What we really need to see in students in the technical interview is the ability to get above our bar. And we only measure up to the low bar, the minimum required skill set to be successful in the DSI. So if you pass that skill set, you could pass it by a little bit, you could pass it just on a margin, you could pass it by a whole lot. We're not looking above the bar. We're just looking that you meet the bar, and our goal is to get you there. So we're facilitating you getting over that threshold. Yeah, and that really includes, the short story of that is, can you express statistical concepts with Python? Can you explore, probabilistic and statistical concepts with Python? And that's really what we're testing. This may, I definitely don't want to be patronizing by saying anything like this. This is really from the heart. Respect that you're a beginner. If you're a beginner, respect that, right? Understand that you are going to be looking at new things that are likely going to challenge you at times. And some of those things will be challenging, some of them won't. The challenge of those things is your process of learning. And, it's important to build a relationship with the aspects of this that frustrate you. I think that's very true in math spaces. I think it's very true in technology spaces, because a lot of what we end up doing is actually troubleshooting our environments. It's troubleshooting our code. It's very, very rare. I had one student once who coded end to end a complete battleship game in C++. This was a student I worked with, and he ran it. He built it. He compiled it. And it broke in its compilation on the first run. He had never run it before. He fixed, like 3 or 4 errors, and then it ran perfectly as he expected. I've never seen anything like that before or since. Nobody codes like that. Everyone codes by writing bad code and incrementing it toward good code. Everybody writes by not understanding something and incrementing it toward a reasonable solution. That's the world that we live in, and that's really fun. So if you approach not understanding something from the mindset of, I am going to understand this and I'm going to increment myself toward that understanding, then you're really solving some interesting problems. You're solving a deeper problem, kind of in your personal relationship to those challenges, but you're also actually solving the problem in front of you. And that's a big part of what being a developer is about. It's definitely what being a data scientist is about. You are always approaching solutions that you don't necessarily understand, and you're trying to understand them. And that's really where the challenge and the fun is. So yeah, if you can't do it now, you will be able to do it soon. And trust yourself in that, and try not to get too frustrated when you see error messages. Error messages are your friends. They really are. And they're going to help you solve the challenges in front of you. There's kind of a bit of information here on a growth versus fixed mindset. That's really a reiteration of what I was just saying. Challenges that are in front of you, embrace them and see them as, okay, I'm on this interesting path. And don't give up on it. It's something that, if you don't give up, if you keep going after understanding, you will get to a point of understanding. This is thinking critically. Now, this is something I really like talking about, and I'm going to try not to talk about it too much right now. So, yeah, a lot of people will focus on the technologies, the programming, the math, all of this stuff when they start into data science. Now, thinking critically is not very easy for us as humans, okay? we are just riddled with biases and cognitive biases and misconceptions. And if you get the chance and you want to have a really good time and analyze just everything, maybe, everything that's broken about the way you and everyone around you sees the world, there's this wonderful list of cognitive biases in Wikipedia. And in most cases, I can pick one of these at random and be like, oh no, I definitely do that. So I encourage you to just, to kind of keep this brief. I encourage you to analyze the way you think about things. That's a big part of what being a data scientist is about. And, you need to be open to being wrong. You need to be open to having a wild misconception that you've never been aware that you have, right? And that's just really important. So I won't fixate on that for much longer. I'll just leave that there as a link. So we looked at Learn already. There are two other things that I want to show you. And these are going to be probably your, if you haven't coded much before, these are going to be your initial coding environments, likely going to be your initial coding environments. One of them is REPL.it. We call it Replit. Actually, Clark, do you want to, if you don't mind dropping a link to that? So Replit gives you a full coding environment for Python and for other languages as well, but it's, we find it specifically helpful for Python. So the way that I'm going to make a REPL here is I'm going to click on this plus sign up in the corner, right, up in this top right. And I'm going to click on Python. And it automatically makes a name, delectable, inconsequential firm. Obviously, that's random. And I can create this REPL. And what this gives me is a coding environment as soon as it loads. It can be a little bit buggy. It can crash sometimes, but in general, you can just refresh the page and it'll be fine. So I'm just going to write a quick function here. So here's the factorial function. I'm going to take the factorial of n. So I make this, I make this kind of accumulator thing. And I say for number in range, and I'm going to take every number from 1 up until n, including n. And I'm going to multiply that product by that number, and then I return the product. And then, so I have this function, and I can run the function in this space. So I'm going to take the factorial of 5, and I would expect to see 120 as my output, and I do 120.0. So I might want to think about that. This should actually just be a 1 because we're counting, but this is a full coding environment, and you can use it as such. This is one of the, the most immediate places where you can write code, commit code, test code, and get a feel for it. The other one that I'm going to point at is called Google Colabs. Google Colabs is a bit different. It's based on something called Jupyter Notebooks. Jupyter Notebooks, if you're in the Python domain, especially in the data science domain, you become very familiar with Jupyter Notebooks because you use them for, kind of your exploratory analysis. You use it to share code in various times. Google Colabs are kind of incredibly powerful, as it turns out. And so I'm just going to make a new notebook really quick. And this is a somewhat different paradigm for coding than what I just showed you, but I'll show you also that it's not that different. So I'm going to copy this factorial function, and I'm going to throw it into this code cell in Jupyter Notebooks, and I'm going to run that. And it's going to take a second to run because it has to build the environment underneath it, but then it gives me some output. And really the thing here is that you have these different cells. You have code cells, and then you have text cells. So here's a text cell. I'm just going to say, hi, I'm a text cell. And if I run that, I get this header that says, hi, I'm a text cell. So you can both write code and take notes in a Jupyter Notebook. That can be very helpful. So both of these environments exist. Feel free to use either one, especially in these first couple weeks. When we get further along, we're going to encourage you to use VS Code, which is the local text editor. Actually, it's the place where we're looking at the notes is actually in VS Code. And maybe I can run something in here really quick. So let's go into src. I'll go into Python, and I'm going to just make a quick file, and I'll just demonstrate that this file exists. I'm going to paste my code into there, and I am going to run this code in my terminal here. So I'm going to say python delmi.py, and notice we get some output here that says 120. The goal for you in like week 3, beginning of week 3, or roughly around that, is to have a text editor like VS Code, preferably VS Code, installed and usable on your local machine. And you can do that sooner than later. That's totally fine. So let me get back down to where we were at. Okay. And I'm just going to wrap up with just a restatement of Slack etiquette. If you're asking a question about a specific challenge, make sure you paste a link to that challenge. It's really hard for us to help you if we don't know where that challenge is. And, try to form your question, pretty well. And also, if you're replying to someone else's question, then keep it in the thread of the original post. Also, don't just give people the answer, right? Lead them forward with the Socratic method. That's definitely preferable. Yeah, that's really it. So I'm going to open up for questions right now. If you have questions about anything I covered, post them in the Slack. Don't come off mute, but post them in the Slack, and I'll do my best to answer them. And then we'll take a quick 5-minute break, and I'll hand off to Clark. So feel free, ask any questions. Is there any way you can get into the May cohort? So the May cohort starts May 17th, which means that our cutoff date for interviews, you know what, I'm just going to look this up so that I don't give you the wrong date. So the interview deadline is April 26th. Thanks. Is there any way you can get into the May cohort? Possibly. If you can pass the technical interview before May 26th, then you can get into if you can pass the technical interview before April 26th, then you can get into the May cohort. That's really contingent on your background, what you've done technically. The place that I would start, my recommendation would be to watch the technical interview playlist. Since you're in premium prep, you would get a 1-week extension. That's our general policy there. So there's that extension, but beyond that, we don't give an extension because there's a lot of materials that you need to complete before day 1 of the DSI, actually. Yes, you also have to pass the coding challenge. The coding challenge is relatively easy in a lot of ways. It's just you're essentially writing 3 functions, and you can try it out as many times as you want. You can try to pass it as many times as you want. We do that as a kind of a simple gate mechanism so that we're not interviewing people who don't know Python. That's really why that's there. So, anything that's in the technical interview is not more difficult in terms of the Python than what you would do in those coding challenges. So let me finish answering this getting into the May cohort question. The place that I would start is with that technical interview playlist on YouTube. So let's just go to that. And I'll paste this this playlist in. So it's, oh my gosh, it's somewhere. All right. You know what? I think if I just do, there it is. Okay. I would go through and watch these videos. If you feel capable of coding any of these things, if prompted, you're likely ready for the technical interview. That's one of the ways that you can self-assess. Yeah, that's pretty much what I have to say about that. You can also meet with one of us for a one-on-one to figure out where you're at. And if we gauge that, oh, you're within a week or a couple weeks of the technical interview, we'll tell you that. We'll say, yeah, you seem pretty close. Focus on this and this, and you're likely going to pass. So yeah, just keep that in mind as you're looking at preparing for the technical interview. Let's see. Is it okay to ask questions on challenges you're stuck on in basic prep that the cohort is not currently covering? Absolutely. Yeah. Oh, sorry. Clark already answered that. Yeah, definitely outside of class time, or depending on our availability at the end of class, when we just open up for general questions, there are a lot of times where you're like, hey, I'm stuck on this thing. Can I ask about it? And we'll be like, oh yeah, we have time for that right now. So that's more an end of class thing at that time. But yeah, we're definitely open for questions that aren't geared toward the immediate thing that we're covering. If you happen to pass the TI, can you still attend these courses? Yeah, definitely. You can definitely come to these. We do cover some materials that are kind of heading into the DSI. We have some kind of post-TI materials, especially in the last week or so. Things like error handling, writing classes. I do an intro to machine learning class that covers, like a class and a half. And I think all of those are, I think those are fun. And I definitely would encourage you to attend those, even if you've already passed the TI. Will there be instruction on how to set up GitHub? Setting it up. Well, in terms of setting it up, you can just register for GitHub. Getting used to using Git, we've got a section, we've got a unit on that in our materials. That's more something that I'd be inclined to have a one-on-one and take you through some of it. We have kind of a lot of video on it actually too. So I'm happy to share a simple workflow for Git. I think Clark would be happy to do that too. So don't hesitate to ask about it when you get to that point, or if you want to do that sooner than later. Is it too late to apply for the scholarship to enter the May DSI cohort? I don't know. It's a really good question. Let me just look that up. So Galvanize DSI scholarship. I'm pretty sure we give an explicit date here. That might be a better question for an enrollment advisor if the date is not here. Oh, so there's the We Stand Together scholarship and the Galvanize scholarship. I don't see the deadlines for the We Stand Together scholarship, but it looks like there are application deadlines here. So, so that looks like, okay. 3/8/245. So it looks like that scholarship deadline is around the 5th of May. I would, that's what it says on this document. I would confirm that with an enrollment advisor. But it looks like, yeah, that there's still time for oh shoot, wait. I'm sorry, that's April 5th. Oh my gosh, yeah. I'm terrible at dates and times. I'm actually terrible at date time manipulation in Python as well. But I think everyone is. Sorry, it looks like that is, the scholarship for the May 17th cohort is closed at this point. for the Galvanize scholarship. Sorry for misspeaking on that. Okay, so the percentage that passed the TI, right now on the first attempt, we're seeing somewhere between 60 and 70%, and we're seeing upwards of 95% on the second try. So almost everybody who takes the interview a second time passes on their second attempt. And we have a fairly high percentage going into the technical interview that passes, somewhere between 60 and 70%. I don't think we have hard numbers on that, but that's classically what it's been the last year or so. And I think we see those numbers because we try our best to communicate exactly, the span of things that you need to know and how to prepare for that. So we'll do our best to continue communicating that well. Let's see. Awesome. Okay. It looks like that's it for questions. I'll be back on at the end of class, and I'll be here with Clark, and we can answer questions at that point too. So yeah, I'm gonna stop sharing, and I'm gonna hand over to Clark. Feel free to take a break, or poll everybody and see if people want to skip a break for today. But
I think I'm going to make the executive decision. We've got a bit to go through. We will have breaks henceforth, but seeing as we have a bit to go through, I could actually make use of the extra 5 minutes. So cool. Apologies. We'll forego the break today, but we will have one. We'll have a 5-minute break in the middle of class henceforth.
Awesome. Thanks so much, everybody. I'll see y'all in about 45 minutes, and handing over to Clark.
Thanks a lot, Tovio. See you soon. Okay, cool. So let me get my screen share up and running. Oh, I hope I have permission here. That's this one. Okay, there we go. Apologies. All right, so we're going to get straight into some Python for today. We've just got some introductory materials to go through. Let me get, apologies, let me get set up here a little bit. That'll do, okay. So this is my coding environment. Let me talk a little bit about this first. You're going to see me. This is going to kind of resemble what we showed you with Replit, just so you kind of know where everything is. I know that the borders seem a little undefined, but this is my text editor area where I'll be doing most of the work. I have the material on over here on the right, and you'll be seeing as I run. As I write code here, I'll write something print hello world, and I'll save that, and it'll run, and it'll print out down here. I have the text set fairly small. This is kind of the way that I like it, so I can see a lot on screen. Can I get put a plus in the chat or two if you want me to increase the font size a little bit. If it's a little small, I don't mind increasing the font size. I know that it can be small for some people, but if it's all right, like I don't want people like squinting and unable to read what's going on there. So, but yeah, so that's what's going on. I've just got my text up here, and if you look down here, you can see my output prints out down here. I'm going to be going over these introductory materials, but first I want to lay out a general framework. I'm just talking about my environment, just so you have a sense of the tool that I'm using and how kind of the parts go together. So this is the Atom text editor. It is my personal preference. It's the open source editor on which VS Code is built on. I don't have anything against VS Code, like philosophically, really. It's a good editor. This is what I learned on, and I just love it to death. I prefer it to VS Code personally, but you all should start using VS Code. Everything that you see me do here should carry over, at least, the ideas should carry over to VS Code pretty easily. So the way I'm using this tool, I just have this down here. This is just a regular bash terminal. It's a regular command line interface into my computer, just like everything. So what IDE am I using? This is, I do not, so I'm sorry. I don't prefer to use IDE tools. I prefer to use text editors. It's just really a preference thing. The distinction is a little arbitrary. There's kind of a gray area, and you could argue that VS Code sits a little more on the IDE side and Atom sits a little more on the text editor side. It's kind of an arbitrary distinction, but it's I prefer this a text editor style tool, which is basically just a raw editor window and a terminal and nothing else. So a text editor is like a very simple kind of bare bones tool. Now, as text editors go, this does have a lot of bells and whistles and a lot of modern features that make writing a bunch of code really nice and cushy. Whereas IDEs have that, plus they will tend to like do a lot of code writing automation. So it's like you can sort of automate the writing of hundreds, or maybe 50 or 20, maybe hundreds of lines of code. I tend to like to do everything myself because I'm ornery or something. I don't know. I'm stubborn and old-fashioned, I think. But yeah, you could look up Atom Text Editor. I do like it, but I absolutely, to be clear, I do recommend that you use VS Code to start off with. It's an industry standard. It's what everybody uses. There are features that are kind of expected to know, so it's worth using VS Code. Like I said, everything you see me do here will carry over pretty straightforward. And when you start using VS Code, you'll start, the way that we recommend is you'll open up the terminal in VS Code. I'll leave that for you to discover kind of as we go. We can talk about how to use VS Code later. But you'll open up the terminal like this. So there will be no, how do I explain this? When I say this is a terminal, this is an interface to my entire computer, right? I can list the elements, the folders in this directory. I can navigate directories. I'm in my home folder. Now I could list the contents of my home folder here. And then CD is change directory, projects. And then I'm in DSI premium prep right here. Right, so this is an interface into my entire computer. So this looks like it's like an integrated part of Atom, but it is literally an interface into my entire computer. So it's a generic tool. And I want you to think about it that way. The way I'm going to run my code, I'm going to use this program that's going to watch the file or watch this whole directory, this whole folder that I'm currently in. And then run the IPython interpreter against the main.py file that I'll be kind of working out of. So you don't need to understand all that for now. I just want to give you an overview of like kind of what you'll expect and kind of how we recommend you start once you get into VS Code. That will become clearer. Cool. Thanks for posting those links too. If you do, so go download VS Code at that link that was posted there. If you want a backup editor or you want to be a feisty old curmudgeon like me and be stuck in your ways in the good old days of 2017 when Atom was the coolest editor on the block, you can download Atom as a backup editor. It doesn't hurt to have a good backup editor as well. I use VS Code as my backup editor, or when I'm required to, which fortunately is never. But anyways, okay. So before we get into today's material, I want to go through an overview. I'm going to teach you everything you need to know about programming basically in like a few minutes here. So like I said, I graduated the web development immersive. One of my big goals with that was that I knew I wanted to break into the technology industry. I knew I wanted to program. I didn't have like a niche in mind. I just wanted to get my foothold in the industry. I didn't really know about data science when I started. If I had, I probably would have gone for that. But I'm glad I found this as a niche. I'm happy where I'm at. And like I said, one of my goals was to be able to learn languages more or less easily, right? Certain languages I've been able to learn like on the couch, watching Star Trek with my partner in an evening or two, and certain languages, might take me weeks, but in general, it takes me a day or three to pick up a new language if it's similar to Python. So I thought a lot about like, what do you need to know in order to have like a solid grasp of a programming language? And I want to go through this because this is something that I really wish that I had when I was first starting out. If you're more experienced, if you know a programming language or you know Python and you're taking this as a refresher, you may find some of this approach to be reductive. It's deliberately a little reductive at certain points. So it's not, and I want to be clear on that, right? Like, this is not a comprehensive, like absolutely everything you could know about programming. This is like, I don't know a programming language and I want to get to the point where I can start using the language to solve problems and then learn whatever else I need to know and have that foundation where you can go learn everything else that you need to know. So what I came up with after learning a few languages and thinking about this is, you want to understand how the language evaluates / executes. You want to understand these things, and this is kind of like, how the program that goes through and reads the code, like, what does it do? Does it execute the code immediately? That's called interpretation. Does it compile that code into a more efficient raw machine language, or a more efficient sort of pre-compiled language that then gets itself interpreted by another language? That's called compilation and pre-compilation, respectively, right? Python, there are pre-compiled versions. Generally, we think of Python as an interpreted language. We'll kind of get into that in a second. But these are details about like the kind of higher level details about the language, how it handles memory, how it deals with the interfacing between you and the interpretation program and the machine. So having a sense of that, you don't need to know everything about it. I certainly don't know everything about that aspect of Python, but having a sense of some of the bulk details, and we will get in more into this as we go. There's this concept of data types. Types are another really important, major topic in programming. I'm going to assume everybody has some familiarity with this. If you've made it this far, you've probably seen some of our material. But just as a quick overview, a data type allows you to deal with information in different ways, right? So if I want to deal with, like, one kind of information is text. right? So if I want to deal with text, I can surround it in quotes, and Python will see, oh, the type of this is called a string. That's what we call the textual type, is a string. And that's the way we represent text information internally in the language. So when we want to deal with, say we want to parse a document and find certain keywords or count however many occurrences of a given word there are, we would Python would understand that text as a string data type. So to clarify, strings handle information on the level of characters, right? If we were dealing with numbers, we don't want to deal with, for example, 6 plus 4, we don't want to deal with the characters of 6 and 4. We want to deal with the actual numeric values of base 10 6 and base 10 4, presumably, right? So these are numbers written this way would be understood as the integer data type, right? So Python needs different ways of handling different types of information. And we can go about understanding those types in part by understanding like what are the applications, what are the applications of each of those types. Like if I want to do math, I want to represent that information in a numeric type that I can perform mathematical operations on. If I want to manipulate or parse text, then I have to use a different type for that, right? So the different applications for each type. And then another one is what operations. So operations are like I showed here. 5 plus is an operation, right? Like what kinds of things can you do to manipulate numbers? So 5 plus 4 is 9. We all know that. This is probably really small. Let me boost that text size up a little bit. That should be a little better. Okay. So plus is what an example of an operation. There are lots of different kinds of operations. They don't always look like a traditional mathematical operator. And we'll kind of get into that as we go too. But these are sort of the bulk categories when you're understanding a new type. These are sort of the big questions you want to ask, like where do I apply this? What are the applications of this type? And what kind of operations are available to me for that type? So we have evaluation, types, abstraction. Abstraction is kind of a funny one because its job is to make our lives as programmers easier, more than it is to make the computer's job as a computer easier. Abstractions allow us to take, imagine I had some process that took me like 40 or 50 lines of code, which is, it's a significant amount of code, right? So if I had a 40 or 50 line algorithm that I needed, and I'm writing a program, that's a couple thousand lines of code, and I have to do this 40 or 50 line algorithm, I don't know, several or a dozen or hundreds or thousands of times, whatever. I don't want to have to write that 50 lines out every single time I want to do that algorithm. It's more efficient for us to, as programmers, as human beings, to write that algorithm out once in a generic enough format that I can supply inputs to and then reuse that algorithm later, right? So that's an example of a function, or a class might also fall in that category. Another simpler example of an abstraction is a variable. So, imagine I have a value that's calculated from several numbers. Maybe, it's a somewhat complex mathematical formula. Rather than having to write that formula out every time, I could save the result of that into a variable, and then I could just use the variable name which has the result of that formula saved inside of it, right? So those are examples of abstractions. So they allow us to give essentially to give a name to a larger process so that we can, all we have to do is remember how that, what that name is and how to use it rather than all the implementation details under the hood, right? So that's abstraction. Another one is control flow. This term I've always found to be, it sounds like it's going to be something like bigger and fancier than it is. Really what it is sometimes I'll call this conditions, which is a little bit of a misnomer, but control flow is the more technically correct term for this, but conditions I think is a little bit more descriptively accurate. So this allows us to write code that will execute only under certain conditions. So we have some keywords for this: if, elif, else, and we'll get into this more, but just know that, obviously we don't want to run our program and have it do exactly the same thing under all circumstances every single time. It wouldn't be very useful. We could just run it once and then we'd know the answer to whatever it did. We want to be able to change things. We want it to be able to be sensitive to, maybe the time of day, or how large your data set is, or the details of your, right? We want it to do special things for special circumstances, right? So this, you can think about this as making your code dynamic and responsive to different circumstances. And the other major important thing is iteration. Iteration, or you could think about it as repetition. This is the heart of what we will call the accumulator pattern. So iteration, repetition, we're going to focus. There are a number of different tools that we can use for iteration and repeating processes. A lot of times when you're constructing an algorithm, your algorithm takes the form of, okay, I have a collection of things and I want to do XYZ algorithm or XYZ process to every element in this collection, right? And that's a repetitive process, right? So you start with the first one and you perform the algorithm on the first process or on the first element, and you move to the second element and the third element, each time performing the process. I think this can seem kind of random, in text of these other ones. With the ability to make dynamic code and abstract algorithms and deal with information of different types, understanding the different execution details of the language, and then just repeating stuff. It's as central as any of the others, I assure you. And it's sort of the the rudiment of a lot of algorithms is writing a loop which will repeat a process. So we're going to focus on two main iteration tactics or thingies. We're gonna talk about for loops and while loops in depth. We will mention other iterators, but it's more like we're gonna kind of touch on those because you'll see them. But these are the tools that we're gonna have you focus on getting proficient with. So, okay. So just to recap that, I'm going to go through, and as we learn new concepts and introduce new concepts, I'm going to kind of try to relate it back to where each of those concepts goes. So for instance, here in the material, which we're probably not going to have time to finish and get through all of today, but that's okay. We'll pick up wherever we leave off tomorrow. So for example, with this material, we have some new concepts about Python being introduced. So let's see. So interpreted versus compiled language. So these are sort of these are questions of like, how does the language work? How is it evaluated? How is it executed? If I wanted to be really kind of pedantic, I put like memory model, type system. If these terms don't mean anything to you, then just ignore them. That'll all make sense eventually. Okay. So for example, interpreted versus compiled, I would put in this category. This has to do with how the language is evaluated and executes. So Python is an interpreted language. Comments, right? This is another one, comments. So you notice, so I'm actually in a Python document here. You might notice, I just take this as a given at this point, but all these lines that start with a hash, these are going to be ignored by the interpreter. And I have some kind of shenanigans going on with these triple quotes, but everything that you see in front of you, all the code here, this is just all going to be ignored. It's all commented out, and a comment is useful for documenting the code in the code, right? So if you want to take a note on something, if you want to just, if you want to provide documentation, like you have, a complicated algorithm that, if you read it, it's not necessarily clear to you what it does, and you want to like just say like, hey, this needs to work this way because X, Y, and Z, or the way you can use this tool is like this, describe how it works in a documentation string. We got a question here. What am I supposed to have downloaded at this point? For right now, you don't have to have anything downloaded. Not for this class. We want you to get VS Code downloaded sooner rather than later. Don't worry about it like this instant. We want you to get Anaconda downloaded. Those are kind of the big two. Those tools just take some time to get used to, so you can really take your time with it. It's certainly not urgent, but we want you to have those things, like we want you to have some experience with those things certainly before the DSI starts. So you can take your time with it in premium prep for sure. Okay, cool. So yeah, anyways, this is basically the overview for today, and we'll just try to get through as much of this as we can. Let me see if I can open this up. Cool. Yeah, hopefully I didn't create the sense like, oh, you got to go download this stuff right now. But yeah, you don't need anything. If anything, just like for next class, I would say like create an account with Replit, and I posted a link for Replit, and then you can have a Replit open and you can kind of code along with what I'm doing. So that's a great starter place, because all you got to do is just go to the site, just go to the URL, and it's like a coding environment just ready for you in your browser. And it's a great place to start. Okay, so what is Python? Python is a general purpose programming language that can be used to develop apps and web apps and software, write scripts, automate operations within operating systems, operate robots and other technical machinery, and more. So general purpose means it does a bunch of stuff. This is in contrast, to a domain specific language. So there are other languages that programmers don't consider programming languages. When we talk about a language being a programming language, basically what that means is it's Turing complete, which means it can model any Turing machine. So Python is such a language. It is a Turing complete language, meaning that it can emulate a complete set of computational tasks. We can do a wide variety of things. For contrast, a language like HTML or Markdown or CSS, or SQL. Those are important languages within the domains in which they exist, but they are tailored to specifically one task. They are not complete programming languages. So you can't write like in-depth, complete algorithms to the extent that you can, or at all, in some of those languages. HTML and Markdown are for structuring documents. They're not for giving a computer instructions on how to solve math problems. They're for structuring documents. How do you lay out a document? What are the colors of the text? How big are the text? Things like that. SQL is for querying databases, for example. So there's some pretty tricky things you can do with querying databases that feel pretty programmatic, but at the end of the day, anything dynamic that's happening in SQL is in the service of querying a database, and that's it. That's the only thing it does. So Python does everything else that the domain-specific languages don't do. So Python is one of many languages used in data science and machine learning. It is by far the most popular. So you'll hear about R, the R programming language, and it's just the capital letter R programming language. That's another one that you'll hear about in data science a lot. We don't teach any R, and I'm often somebody will ask me, like, are we going to learn R in addition to this? We're not going to cover any. This kind of gets back into, after the DSI, if you make it into the DSI and you get through the DSI, you will find learning, if you want to learn R at that point, you will find it easy. Learning your first programming language can feel hard. I'll do my best to make things as easy as possible and as digestible as possible, and to keep things kind of focused in as much as possible, so that help you try to spend your time as effectively as possible, things like that. But learning your first programming language is kind of the challenge. And then once you learn one, learning your second one is just way, way easier. I have never done much R. I've never really gotten into it. I've never needed to. But for example, and this isn't a brag about myself. It's the reality of understanding one programming language well, and this will happen to you someday too. So my partner actually had a class that was in R, and that she's not a programmer at all, and she took this kind of beginner data processing class that was centered in R, and I was like, why is that not centered in Python? It seems a little bit weird, but it was at her university and they chose R, which is okay, but I was able to help her with one of the errors. I just installed R and kind of played around with it for 20-30 minutes, and I was programming R. And it's a significantly different language, but at the end of the day, a loop is a loop. It might look different. A condition is a condition. The types are more or less analogous between languages. So it's just sort of, the differences become trivial rather than like monumental, right? So even though we don't focus in R, we have utter faith in your ability after you learn Python to learn as much R as you want. So, okay, cool. Starting off coding using Replit, I kind of touched on this. This is where we want you to start. If you don't know where to start, like you've got VS Code and Colabs and this and that, right? If you just want an easy answer, just start with Replit. Like I said, you just go to the URL and there's a coding environment right there for you. You've got basically what you see here, which is an editor and a terminal where you see your output. So as you see me work through this, the aesthetic is different than Replit. The colors are different. I have it laid out on the bottom. I think by default, your replets you'll have the terminal on the right hand side instead of on the bottom. I forget, but I like my terminal on the bottom here like this, and however it's laid out, it's essentially you'll get used to it that this is a similar tool to Replit. It's just local and has more nicer features, more fancy, flashy stuff. Okay, so Python is interpreted. So I touched on this earlier. Interpretation means that, let's have a look at this. So this is my program, right? There's no real code in here. Let me actually just cut this out real quick. I'll paste that back in. Yeah, that'll do. So if I wanted to actually write some program, let's just write a hello world. Okay, so here's my hello world program. And all I'm going to do is call the print function, which is going to just display to the whatever console that it's running in, whatever I pass into the parentheses, whatever I put inside of the parentheses. So I'm going to put this string hello world, and surprise, surprise, it's going to write that to the console. It's going to make that string visible on the console. This is a really simple, basic program. It's always like traditionally, like this is like the first program that you'd use. So in order to run this program, I have another program called an interpreter, called a Python interpreter. So I'm going to use the IPython interpreter, and I'm going to start it by saying IPython, IPython 3. That's the command to start the program. And then I'm going to tell it which file I want to run. So that file is in source Python, and then it's called main.py. That's my file name. So, oops, let's see. Oh, I didn't say, I was like, what happened? I didn't save the document. See, okay, so that's another thing. You have to save the document, and then then your code will run. I'm like, what's going on? Okay, so see, it even happens to me constantly. Okay, so that's what ran, and that's what printed on the console. Obviously, that's just what I asked it to print. Okay, so what this program, this IPython program, what that does is it looks at the file and it parses through this and reads each of the commands, and dynamically, as it's reading the file, translates those commands into machine executable code, which the machine executes, and that's your program running. So there's an interpretation process that goes from your text document to abstract syntax tree, which corresponds each of the commands in your text document to commands that the machine understands, and then programming. Okay, so that's what interpretation means. Yeah, there we go. Oh, we got a question here. Oh, I will take this at the end. Actually, I'm going to take the question. Any more questions at the end? So compiled languages. This is just to contrast. Python is not a compiled language. There are pre-compiled implementations of it that will run in a Java virtual machine, but that is beyond the scope of this class, really. So compiled language works a little bit differently. There is you have your source code document. This is my Python source code, right? So with an interpreted language, your source code is your executable. So the source code is the document that is executed. With a compiled language, you have a program called a compiler, which does a really similar job at first, right? It reads through, it parses and reads through the instructions in the text document and translates those into machine readable code, but it takes extra time, and it says, okay, well, I could translate this into this machine code, but maybe I can make that more efficient, and maybe I could like hone that down, and it makes as best the best improvements that it can make, and it will compile it into the best, like the most highly optimized machine code that it can. And then what you end up with is something that where your executable is just the machine code. So the file that is executed is not the file where the source code is stored, right? So you use the source code to produce the executable, and then the executable is literally your program that you run from. And that program its data is stored in unhuman readable machine code. It's readable by the machine, but not by humans. Okay. Some examples of compiled languages are C and C++. This is why, so one of the advantages of writing a compiled language is you can do things like write an operating system, because since that compiled code runs directly on the metal, as they say, or on the machine itself, it runs on a layer potentially below or integrated with the operating system, whereas Python runs inside of a program that sits on top of the operating system or inside of the operating system. So Python is reliant on a program that is reliant on an operating system. C, C++, Rust, other languages that are lower level just run directly on the hardware. So, or they can. Okay. Some documentation links. So I would suggest I'll repost these links after class. This is a link to the Python documentation and the PEP8 style guide. I think it can be easy to look at this style guide and say, oh, this is just for like making your code look pretty. That's not important. It really is important. I see a lot of people. One of the things that I see in the TI is people get sloppy and they write code that isn't necessarily wrong, but it's hard to reason about. Like they don't name their variables well. They leave inconsistent spacing, and it makes the code clunky and ugly. And like, I don't really care. Like, if you can solve problems that way, like, great. I can't really do that, but like if you can actually think in that madness, okay, fine. But very, very few people can code sloppily and really make it work. So it's it's worth putting time into how am I going to do this consistently and write code that's nice to read. If it's nice to read, it's easy to reason about. It's easy to think about. So if it's easier to think about, you can spend time thinking about the problem and not how am I going to make this ugly code work, right? So the PEP8 style guide is sort of, canonically Pythonic things that will help you format your code and write code that is good to work on and easy to maintain, and that you can share with other people and be proud of, and not have to be like, yeah, I wrote this program, it works, but you wouldn't really want to look at the code because it's not that pretty. Text editors, we've talked a little bit about this. I talked about mine. This is Atom text editor. Even though I'm using Atom, I really do recommend that you use VS Code. It is industry standard, so go download that. This is talking about Anaconda. Anaconda is not a text editor. It's a suite of Python and data science tools and libraries that will come in handy as you program. So the interpreter that I use, IPython, comes as part of the Anaconda package. Cool. And this is going to get into a little bit of algorithmic thinking. Let's see here. I think we'll kind of forego this because this is kind of getting into a whole can of worms here. I'm just seeing if there's any other final concepts that we have time to go over. Doesn't look like it. Okay, so we can wrap up here for now. Don't jump off the call just yet. I know Tovio's got some closing words. Here's the homework that we want you to cover for before next class. The beginning of next class, I will take it from how to program here. We'll start with this. I'll probably do just a really quick recap, go over that schema that I went over of types, abstraction, control flow, iteration, and we'll kind of talk about where some of the concepts that we talked about today fall into that. And then we'll start with how to program. I'm not sure if it's on the homework, but yeah, go ahead and do everything in the homework. For next class, have a Replit account created. It's free. I'm not being paid by Replit or anything, but have, if not Replit, some coding environment ready to go. If you don't know which one to pick, just start with Replit because it's so easy to start with. Have that up and running so that you can code along with the examples and start getting used to looking at and working in a text editor style tool. That's the only thing that I would ask for next time. So yeah, we'll wrap up there. We can open up for questions, and I think actually Tovio's got some things that they will want to go through before we wrap up.